Bridex and FIPRES, which is the fire prevention system for LV and MV electrical switchgear and panels. A short introduction on Fuji Bridex. We are a wholly owned subsidiary of Fuji Electric Japan. We have a successful history of 45 years in the supply of electrical components and system in Singapore since 1973. And today we are proud to partner with FIPRES in introducing a fire protection system for early detection of any temperature rise within your electrical panels. For your info, today's webinar will last 30 minutes with presentation from Mr. Bai for about 20 minutes. Thereafter, we will have 10 minutes of Q&A session in which it will be answered by our panelists of specialists, Mr. Shank, Mr. Matthew, and Mr. Bai. So without further delay, I pass this session to Mr. Bai. Mr. Bai, please take it away.
Hello. Let me share the screen. Hope you do you see the screen? I guess you're nice to meet you guys, and I'm really glad to see so many people today. Let me the few words about the Fuji Bridex. We really proud to have the Fuji Bridex as our partner, and as Mr. Peter said, here's the short description of the company. About myself, I would like to say that you can call me Bice for your questions. I'm a product manager at Streamer Electric AG. I have the technical background. My master's degree was in power engineering. I joined the Streamer in 2018, and today I am in charge for our new innovative product, which is called FIPRES, fire prevention and the overheating control system. When it comes to a company, the Streamer designs and manufactures its own solution for different type of equipment in high voltage, medium voltage, and low voltage sector. The idea of these products is increase the safety level, reduce the costs, and ensure the industrial safety. So we have our own R&D office. We have different factory facilities in UK, China, and Russia, and we have international offices in 5 countries. So today we're gonna talk about the FIPRES, as I said before, and let's start with a problem. Then the problem is named the electrical fires. It's quite common thing. The 30% of cases of fire is related with electricity, according to statistics, and for sure it's a huge loss for a business, not only because of material damage. You can see here the distribution board, which is completely destroyed by fire, and it's not only material damage, it's also the profit loss. Let's say if you are a factory and you have your switch gear fully destroyed, you can imagine that the shutdown and will take several days or weeks, and during this time you cannot produce your goods, so it's income loss. And on top of that, it's every single fire is a threat to a human life, which is the most important when we are talking about the safety. And the goal of today's presentation is to understand what's the source of this fire, what's the problems behind this problem, and how we can avoid it or prevent. So here you can see the list of typical reasons of overheating and further fire. From the left side, you can see the list of problems. and the list of solutions. And this list is sorted by frequency. So you can see here the loose connection is the most often thing which can lead to a fire, and a wrong sizing of cables or bus bars is the least often thing. As you can observe from the list, there are some standardized solutions which are mandatory to use, like AFDD or RCD or GFP, and because they are standardized, you can easily find it in every single electrical panel. Let's say the circuit breaker with overcurrent threshold, you can find in any single panel. But when it comes to loose connection or aging, there is no such standardized solution. And even though it's a very common problem, and it's really a problem, but there is no standardized solution, as I said before. So, and here where FIPRES can be extremely useful, and I will explain you why in a couple of few slides. So FIPRES can deal with loose connection or aging or improperly selected equipment because it can detect the overheating on the early stages. About the loose connection, which is the most common thing in the electrical panel, how it happened and what it can lead to. So every loose connection starts with the poor mechanical connection because of different reasons. You can see them here. Is improved torque during assembly, or some vibration if you have the motors on the facilities, or current and temperature fluctuations and expanding and squeezing the contact. And for moving contacts is the decent number of withdrawals. Let's say the circuit breaker, you put it in, out, and after 100 times, this connection get loosened. So these reasons leads to mechanically loose connection, and this mechanically loose connection leads to overheating. As you can see from the graph here, the higher pressure is, the lower resistance is. But because we have the mechanically loose connection, the pressure is lower and the resistance increases. And this increase of resistance provokes overheating because of Joule-Lenz law, everybody knows. And this overheating leads or provokes the oxidation, because the oxidation happen faster and much stronger at high temperatures. Here on the graph, you can see that the contact connection, the Cooper contact connection, and the contact resistance at the initial time is only 1 milliohm, which is totally fine. But after 10 hours at 100 degrees conditions, the resistance increases dramatically and it becomes the 10 ohms, which is huge value for a contact connection resistance. So the oxidation accelerates growth of resistance, and this increasing of resistance causes even stronger overheating, and stronger overheating provokes even more resistance, and you start to have this uncontrolled thermal runaway, which at the end will lead to a fire. We have some solutions on existing market to prevent the fire or prevent the overheating. Let's go through them quite briefly. Well-known fire systems, but you know it works only when the fire already starts. It's not preventive. It's not for sure continuous. Affordable and easy to implement. It's discussable questions. It depends highly on the type of the fire system. But in general, it's not so cheap. Infrared thermography, which is used in most of the factories and the utilities now, it can be not so preventive because it has the limited visibility and limited accessibility. You cannot check every single spot inside the electrical panel because you just cannot see them through this camera. If you have the long period between two inspections, let's say if it's 2 years or year, the problem can occur and lead to a fire between these two inspections. In that case, we cannot say that infrared thermography is a preventive solution. And it's not continuous as well, because it's periodically, it's time to time. Yeah, it's not continuous at all. But it's kind of affordable, and it's really easy to implement. Just need to buy a camera and teach someone to use it. Also, there are some different temperature sensors on the market. You can see the examples here. They do measure temperature and send this measurement values in the 𝗙𝗏𝗍𝗏 or 𝗙𝗏𝗍𝗏 system. It's definitely preventive, and it's definitely continuous, but it has this technology has some limitation, and this limitation are mostly related with installation and mounting process, because to install this temperature sensor, there are too many limits. You cannot install it in low voltage compartment when you have a tough space, or you need to buy extra accessories to be able to install it. Yeah, and it could work for medium voltage switchgear, which is big and you have plenty of space inside, but for low voltage compartment, it doesn't work. And the price of every single sensor is quite high, so we cannot say that the solution could be affordable. And for now, it's used only in like top high-end data centers and stuff like that. For FIPRES, it has all the advantages of the temperature sensors, because it's preventive and continuous, but also it's really affordable, and it's very easy to implement. And the degree of penetration for FIPRES is higher than 90%, which means we can equip 90+% of concerning points inside the electrical panels. And how it works? Yeah, the main element or main device in this system is Remote Fire Prevention Thermal Label, RFPT. It's a sticker. It has two parts, the yellow part and white one. White one has these 3 thermal indication dots, and this yellow one has the signal gas encapsulated inside. So there are millions or billions of microcapsules with the safe signal gas inside. So this sticker should be glued to contact connection or to the bus bar or to cable lug, and the gas sensor should be installed in the same volume. When the contact heats up to, let's say, 70 degrees, the dots irreversibly change its color to black. And it's one-time indication, and even if the temperature drop down to 20 degrees, let's say, the dots will remain be black. And it gives clear information to maintenance personnel that something happened since the last visit. So when the contact is heated up to activation temperature of the sticker, it's 100 degrees. You can see it here. The gas from yellow part, which is encapsulated there, is starting to be released from the sticker inside the switchgear. So it's spread inside, and the concentration of this signal gas is rising, and this signal gas is detected by FPA. FPA is a fire prevention alarm. So FPA detects the gas, it generates alarm signal that something went wrong, and it sends this signal via Modbus to 𝗙𝗏𝗏 or BMS system, or via dry contact output, which is a discrete relay. You can connect it to a buzzer or a lamp or local fire alarm system. This FPA through the Modbus can send the information directly to 𝗙𝗏𝗏 system, or it can send the information to a hub, which is FPC. It's fire prevention concentrator. It's a hub for FPAs. It can gather information from 32 FPAs. You can see the event log there. You can go and check what happened, when it happened, and which sensor has been triggered. And as well as FPA, FPC can transmit the information further to file alarm system, to SCADA BMS system, or it can send the SMS to duty personnel. So in a nutshell, it works like that. Now I want to show the video. Sorry, I don't know how to activate this video. Okay, sorry, it's a picture for some reason. Yep, sorry. Yeah, this how it works in real life. 2 minutes. Let's check it out. In some demonstration case, we have here MCBs, thermal controller, and the bus bars. Behind these bus bars, there is a heater, and the temperature of this point is shown here. This is the FPA, and the dry contact output of FPA is connected to short circuit device. Sorry. So what you need to do? This is the RFPT, the smallest sticker in our range. It's used for small volumes like 100 liters. So we need just simply glue the sticker to a bus bar. And now we switch on the circuit breaker. So, and at that moment, the heating starts. You can see the temperature is rising. Now we see we should control these thermal indication dots. You see at the 50 degrees, the first thermal indication dots gets black. Now we're waiting for 70 degrees. Yeah, at the 70 degrees, the second dot gets also black. Now we're waiting for 90 degrees for the last dot and for 100 degrees for gas releasing. As you can see at 90, we have all 3 dots black, and now we're waiting for 100 degrees. You can see here that FPA is glowing with green. The LED indicator is green, which means the FPA is in standby mode. And as soon as it detects the gas, and decent amount of signal gas, it changed the color to red, which means the alarm mode has been activated. And the dry contact output closes, and the circuit breaker should switch off. Yeah, you see at 99, when the sticker hits up to 100 degrees, the signal gas goes out and the FPA triggers and the switch off the circuit breaker. Let's check it again. At 99, it happened at 99. Yep, that's how it works. That's how it works, the example of operation. Let's go further. And let's talk about the preventiveness of FIPRES. Here you can see the typical scenario of fire inside the electrical panel. This curve is, let me pointer laser. Yeah, this curve is the temperature of the contact connection inside the electrical panel. Let's say the incoming cables connection. Okay. So if you have the poor mechanically connected connection, it has a bigger resistance than the normal one. And with some high current, this contact starts to heat up. When it heats up, it accelerates the oxidation process, which means the next time the overheating will be stronger. and next time it will be even more stronger. This process can take several months or half year, but at the end of the day, it will go to this degradation of contacts and insulation stage, which means that cable insulations is completely degraded. So breakdown voltage becomes low. The metal part of the contact is fully oxidized, and every single overheating after this stage can lead to a fire and uncontrolled rise of temperature and then fire. So fire itself usually starts around 300 degrees because the cable insulation starts to smoke and melt approximately at 280. This is zone where the fire can be detected by fire system, but as I mentioned before, it already has some decent damage of the equipment. What we propose and what FIPRES propose is to detect this abnormal overheating in this gray zone. So FIPRES can detect overheating at 90, 100 degrees, 130. This is far away from the fire. You see the difference to 180 and 100 degrees, for example. We have different type of stickers. The sticker I showed before is for 100 degrees. Also, we have stickers for 80 degrees and for 130. So the normal case of using FIPRES looks like that. After the very first detection by FPA, it sends the alarm signal to maintenance personnel. Maintenance personnel goes to electrical panel, do some repair, the contact cleaning or replacing some parts, defective parts. This repair job is quite short. And after this repair, the contact gets normal back again, and it's not prone to be a problem in the future. So, and FIPRES detects the overheating and possible fire and damage not like 5 minutes before fire starts. It detects the fire like months before it starts, or half year before it starts. So it's really, really early preventive notion of the FIPRES. Let's talk in more details about each product. It will be short. The RFPT, or sticker with signal gas, we have different sizes for different size of compartment, because every sticker has different amount of signal gas inside. And we have this one for 100 liters of compartment, and this big one is for 3 cubic meters electrical panel. We have different levels of activation temperature, 80, 100, 130. The sticker for 100 degrees is the standard one. The other one for some specific projects. And every single sticker has 10 years of a lifespan. When it comes to FPA, we have two different types. The first one is the single body FPA for low volumes, less than 1 cubic meter. And we have the FPA with 4 corded sensor. Inside each one, there is a gas sensor. And it could be used for large compartment or for compartment with the 4 sections, like an example here. We have corded sensors here, 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 and here, and they all are together connected to main body of FPA. As I said before, it can send the information via Modbus. It has the discrete output relay. And let's talk about the detection process and how it works. So FPA, the principle of working is that FPA constantly checks the ambient air for presence of signal gas. The FPA is very, very sensitive. The real sensor sensitivity is 10 ppm. The ppm is the parts per million, somehow the concentration. But we use the threshold, the artificial threshold of FPA, just to avoid triggering by some foreign gas. Because let's imagine you are in a chemical plant, there are some gases in the ambient air. Yeah, and just to be sure that we are not misoperate, we use the threshold of FPA. And then let's imagine that we have 1 cubic meter of the volume, and we put one sticker for which is size 15 to 2 centimeters in size, and we put it inside 1 cubic meter compartment. So when this sticker is heated up to 100 degrees, it generates up to 400 ppm of gas concentration inside this volume. And this is where FPA can detect the signal gas. As you can see, 400 ppm of the concentration and 150 is a threshold. So the safety margin here is 3 times higher than it's needed for reliable detection. And this principle works for every size of sticker and every volume of compartment. We are trying to double or triple the concentration that is needed for detection. FPA also has auto calibration feature, so it's adjusting to ambient environment, understand where it's placed, what's going on, and adjust its zero level to ambient conditions. This technology is named the zero drift technology. Yeah, also we have some auxiliary product, which is VFPT, or Visual Fire Prevention Thermal Label. These small stickers are needed for visual inspections. They don't have any gas inside. It's just the same material as the round dots on the RFPT. And as soon as sticker is heat up to activation temperature, let's say 90 degrees, these white strips gets black irreversibly. So yeah, you can just stick it everywhere inside the electrical panel and check in 1-2 weeks, and then see which stickers gets black, and that will give you a clear understanding which connections are not tight or some degraded. And as well as our stickers with gas, it has 10 years of validity period, or 10 years of lifespan. And we have different size and activation temperature in the product range. Where FIPRES should be used? Yeah, let's start with the switchgear. It's one of the obvious example, because the switchgear is very expensive, and it's very important part of electrical supply. So here we recommend to install the RFPT on the bus bar connections, because these connections are made on site. It's a big chance that this connection get loosened with the time. For sure on the contacts of circuit breaker, because it's withdrawable. Every time you put it out, put it in, the contact gets worse and worse. The current transformers connections and incoming cable contacts, especially incoming cable contacts, because actually it has 2 connections on this one cable. The first connection is between the cable and the cable lock, when you shrink in the metal part of the cable. And the second connection is between cable lock and metal bar here. So, and then also the cables are prone to vibration and some shock currents. So we need to ensure that RFPT is installed there. And for voltage transformers, also because it's withdrawable, it's moving contact, it's really gets worse and worse with the time. And yeah, we need to ensure that this connection is under control. Corded sensors we use usually for switchgear. We use 4 corded sensors, and each sensor we place in different compartments. So in the bus bar compartment, in the incoming cable compartment, in the circuit breaker compartment. So in case this RFPT is releasing the gas, this gas will be caught and will be detected by this corded sensor. If the RFPT releases the gas from here, it will be detected by this corded sensor. This is the photo of the examples. It's a circuit breaker, withdrawable circuit breaker. And this is the RFPT of XL size. This is the current transformer contacts equipped with the FIPRES. That's how you can how you can install the corded sensor. Usually it's mounted on a DIN rail, and the FPA, the main body of FPA is should be installed inside the low voltage compartment to be easily observed by maintenance personnel because it has this LED indicator. The MDB panels, also corded sensors, and RFPT for incoming cables. This is feeder panels for it's factory new. It's equipped with the FIPRES from the factory. Yeah, this is the FPC inside the low voltage compartment. As a conclusion, I want to say that FIPRES works much early than any fire systems. It prevent the fire and any damage a few months before it happened. It's continuous, 24/7 monitoring, and it's really easy to install, easy to implement for factory new equipment, and to retrofit the old one. It has the connectivity to SCADA and BMS system, and it has the long lifespan, 10 years. That's it from my side. We'll be glad to answer on your questions.
Hi. Do any of the participants have any questions? Please type it away. Click on the chat and type your questions, and the panelists will try to answer your questions. If we are unable to answer, we'll come back to you.
I think we can start with the questions are already on the chat, maybe.
Yeah, I'm trying. Okay.
One of the questions, Bryce, was that means we need to buy both FPA body and the sticker sensor. It has to be the alarm if there is fire or heat. So basically, the question is whether you need to buy the stickers and the FPA sensor, and that the FPA will trigger an alarm in case there's overheating or fire.
Okay, yeah, sure, because the FPA is a gas sensor, and it detects the gas which is being emitted from the sticker. So we need to two things. They are working together. It has to be alarm if there is a fire. Now, when the RFPT and the sticker with gas releases the gas, it's not a fire at all. It's like overheated conditions of the equipment. And it's far long before fire. But if you are talking, if there is, let's say, fire in the neighbor compartment, in the neighbor panel, and it's smoking, etc., etc. Yeah, the FPA, I think, should detect this high concentration of smoke in neighbor compartment. It's like additional feature, but it's not purpose. What's the composition of signal gas? Yeah, it's the 𝗙𝗘𝗍. 𝗙𝗘𝗍 is a freon, is a safe gas. It's not toxic. It's not flammable. It has no flash point, which means it cannot explode or lead to explosion. Yeah, it's eco-friendly, I guess, because it's don't destruct the ozone layer, etc. Is there a possibility if FPA fails to detect the gas leak? The principle how we ensure that FPA detects 100% of the time the gas is we put inside the sticker, let's say, a few times more gas than it's needed for detection. Let's say for detection, it's needed 150 ppm. of the gas we put inside the sticker 400 ppm, like roughly talking. So yeah, no, it's in normal condition. It shouldn't get failed. So no worries. Can we get the PDF brochure? Yeah, Fuji will send you all the information. You can contact them.
Yeah, Bryce, maybe we can add that that on the FPC we have a way to check the FPAs, and we check the proper status of the device.
Okay. Yeah, sure. Thanks, Matt. Thanks. Yep. The FPC is controlling the FPA, and FPA every time sends the information about its status to SCADA BMS system. It's like sends the information that everything is okay with me. Don't worry. Or if there is a trouble with some connection issues, it sends the information that check me that there is something went wrong. For testing of the gas sensor itself, we also have different testing kits. And yeah, for let's say annual maintenance checking, we also can provide tools to test out the FPA. Can we get the PDF brochure? I answered. Yes, Fuji will send you all the information. What's special for this label? Still it works with by duct or low temp environment. The temperature of operation is from -20 to +60, and the temperature of operation. If it covered by dust, I guess by dust, yeah, it doesn't matter, because the capsules at 100 degrees just bursting, or just because of the pressure inside, and this gas is spreading out. So no problem. What will be the cost? I can say that it's affordable, but all the cost details you should receive from Fuji Bridex. Can these labels incorporate during the fabrication of switchboards? Yes, I think so. You need to talk to.
Vice, if I may, I'm not sure the gentleman asking about the duct really mean the dust or the duct, but if it's a duct, the answer is that that the label needs to be in the same compartment as the FPA. If they are not within the same compartment, the same volume, the FPA cannot sense the gas, of course. So if you put a duct above your cable and the FPA is not within your duct, there's no chance for the FPA to detect the gas coming from the stickers.
Okay. Yeah, thanks for your remark. I misread the question.
Regarding the cost, Bridex will be able to answer this.
Yeah, I don't see any questions in the chat.
We will have the cost given to our sales, and once you write us at info@bridex.fujielectric.com, we'll be happy to send you a list of the prices. But now we don't have any published prices yet. And one of the questions is reference cases in Singapore. FIPRES is very new in Singapore. It's I think we're the first party here, and definitely we are trying to work for references. But right now, I think we are the first few to look at it. So there are no references at this moment. But I believe it will come in due time, and we will release this information either online or to customers who want to know more. But at this moment, the answer is no.
Yeah, probably what we can outline is some of the products have been installed in schools. They have been installed in switch gears MV up to 35 kV with ABB, for example. Vice, you can probably share more installation cases. You are muted, Vice.
Sorry. Yeah, right. Thank you. Yeah, we have installed. Yeah, it's definitely a new product for for international market, but we have some experience and the list of successful installations in domestic market, which is Russia. There we have oil and gas companies like Gazprom and Rosneft. Chemical plants are highly interested in the product because the high cost of outage or shutdown. Subway stations and for sure the social objects. Internationally speaking, now we are working in the Middle East region for high-rise buildings because it's really important topic, the fire safety in such building, and as well as all the industrial companies. Yeah, as I said before, interesting to get. I can send. I will send to Fuji the list of installations and references. We can discuss it in more details after. The labels.
There's another question about within an electrical panel, how could we determine the best location to position the FPA so as the FPA effectively detect the signal gas in the shortest time?
The best location, okay, the best location is on top of the panel because initially this signal gas is lighter than air and it goes from the bottom to top. So we need to put it higher than the RFPT, and yeah, that's the main recommendation. The other recommendation, okay, you can put it closer to FPA or to RFPT to increase to shorten the detection time. So the answer higher than RFPT and closer to RFPT. Apart from heat, what other cause the labels can release the gas? Yeah, nice question. Actually, the capsules are bursting because of pressure, and this pressure can be generated by two things: the high temperature and the high mechanical pressure itself. If you squeeze the sticker with the enough pressure, it can also crack some capsules. But yeah, in normal operation, it's only heat can lead to capsules bursting. How is the testing and commissioning conducted early to ensure the sensor are working? We have kit. We have a special can with the signal gas there, and you just should spray it towards FPA. We have recommendation how to do, what to do, and yeah, all the recommendations we will provide. Yeah, seems. Don't see any new.
One question that comes so far often is whether the sticker can actually burn or catch fire itself. So, Bais, what is the answer to this?
No. Actually, yeah, you can show if you have a sticker with you. You can show some.
So it's self-extinguishing material, right?
Yeah, when you're trying to light up, to burn the sticker, it releases the gas because of high temperature, and because this gas is fire extinguishing, it doesn't allow to sticker to catch the fire. That's the main idea.
Basically, here is a sticker, so I don't know if you see it clearly, but okay, I can try to light it up, but you will see that it's self-extinguishing.
Yeah, you see this. You can hear the sound. This sound is the bursting of capsules, which doesn't allow to fire be catched, the sticker be catched by fire.
So yeah.
Any more questions from the participants?
Yeah, I see the question. Okay, a recommendation. No, there is no recommendation when to change. It's the only reason why I need to change the sticker if you have 3 dots black on the sticker. So 50, 70, 90 degrees. And if all the dots black, it means that most probably the sticker released some gas outside, and it should be changed. If all 3 dots are white, or let's say if 50 and 70 only are black and 90 is still white, you can easily just don't change the sticker, yeah, because the lifespan is 10 years. We have a kit to test it out, like the stickers for, like, let's say early commissioning. Yeah, but the recommendation is simple. If there is no 3 dots black, you don't need to change the sticker.
I think it's important to mention that there's no gas that is actually going out of the sticker unless you reach 95 degrees, where gas starts going out, but very little, and then the majority of the gas is really released at 100 degrees. So below this temperature, as long as no dot is black at 90 degrees, there's no chance that the gas went out. And this is precisely what we test at the factory, at the production site. And this is one of our product acceptance tests. So this is what we verify precisely with the stickers, is that no gas is released unless it's really reaching 100 degrees. So this guarantees that this sticker at normal temperature will keep the gas. And this is also why we indicate on the label the batch year that is written here. So you might not see it, but it's basically the expiry date is usually 10 years after the production. So we give 10 years as a lifespan. The idea of this 10 years is that in normal temperature, that means below 90 degrees, 95 degrees even, there will be no gas coming out of the sticker, and therefore you can use them and keep them for 10 years. So of course, if you reach 90 degrees, you will have obviously to look why there's overheating at that location. And if you wish to test the stickers, of course, every year you can randomly test one of the sticker, verify that the sticker is still igniting the FPA, and then replace that sticker. And for this, as Vice mentioned, we will have a testing kit. Any recommendation? Another question is, what kind of panels would you recommend for implementing this system? Is there a minimum size of panel to implement this system?
There is no minimum size. What kind of panel? Actually, that's any electrical panels, but I just wanted to highlight, I forgot to say this during the presentation. The electrical panel or compartment shouldn't be with the forced air ventilation, or if you have some cases with forced air ventilation, you need to contact us, and we're trying to figure out what can we do in this scenario. But the less size of the panel, it means the higher concentration of the gas will be inside this electrical panel. It's even better, let's say, to have this small compartment. Yeah, so there is no minimum size. For the maximum size, I can say it's like 3-4 cubic meters, but I didn't. Yeah, I mean of single volume. If you take the switchgear, which is big, but it has different compartments inside with the closed volume, and yeah, I mean the 3-4 cubic meters of one volume, but I didn't see such big single body compartments so far. And so for now we are pretty pretty sure that we can equip almost every single type of electrical panel. I think we should finish.
Yeah, I think there is no more question from the participants, but if you do have any questions, do so-called get in touch with our salespeople, and you can email to us at info@bridex.fujielectric.com. Okay. With that, I think it comes to the end of this webinar. We'd like to thank all the panelists, our speakers, and participants for your time. And we hope that we have answered all your questions in this short session. If you have any further question, please contact our sales personnel or email to us. And for more information, you can actually log on to our websites to check on our product. So for questions that we are unable to answer today, we will get back to you as soon as possible. So with this, we thank you for coming to this webinar. See you again.
Thank you.
Stay safe.
Have a good evening. Have a good weekend.
Thank you all.
Thank you.